term that we'll start off with today is what is called compound ratio. If the ratio of terms A and B is given as A is to B, the ratio of terms C and D is given as C is to D, then the compound ratio of the terms is given as AC is to BD. And this holds for two terms. Similarly, if the ratio of A and B is given as A is to B, the ratio of two other terms, C and D, is given as C is to D, and the ratio of two other terms, E and F, are given as E is to F, then the compound ratio between these terms is given as ACE is to BDF. Duplicate ratio. As the name suggests, if we have to find out the duplicate ratio between two terms, A and B, then the duplicate ratio is given as A square is to B square. That means both terms are squared and we find out a ratio between these two terms. It can also be mentioned as the compound ratio of two equal ratios. If we have two equal ratios, A is to B and A is to B, then the compound ratio between these terms will be given as A square is to B square. So the duplicate ratio between two terms can also be said to be as the compound ratio of two equal ratios. Triplicate ratio. Triplicate ratio, if the ratio between two terms is given A is to B, then the triplicate ratio is A cube is to B cube. If the ratio of two terms is given A is to B, then the triplicate ratio is given as A cube is to B cube. It can be considered to be the compound ratio of three equal ratios. They can be considered as the compound ratio of three equal ratios. If we have three equal ratios, then the compound ratio would be given as A cube is to B cube. Then we come to what we call sub-duplicate ratio. If we have the ratio between two terms, A is to B, the sub-duplicate ratio is given as root A is to root B. The sub-duplicate ratio between terms A and B, that is A is to B, is given as root over A is to root over B. Similarly, we have sub-triplicate ratio. If we have the ratio between terms A is to B, the sub-triplicate ratio would be the cube root of A is to cube root of B. Cube root of A is to cube root of B. And then we also have a term which is called reciprocal ratio. Reciprocal ratio means the ratio of A is to B given as 1 by A is to 1 by B. Reciprocal ratio of A is to B is given as 1 by A is to 1 by B, which will finally imply that it will become B is to A. So the reciprocal ratio of A is to B will be B is to A. Proportion is generally when we have two ratios and we have to equate those two ratios, which means if we have A is to B equals to C is to D, then we say that the numbers are in proportion. Here, we will find that since A is to B equals to C is to D, that is A by B equals to C by D, implies AD equals to CB. From here, we devise a formula which is used often, product of extremes. Why product of extremes? Because A and D are the extreme terms, is equals to product of means. The terms B and C are the mean terms, that means which are in the middle. The ratio that is given to us, A is to B and C is to D, since they are in proportion, we are considering them to be equal. From there, we are getting A by B equals to C by D, from where it follows that AD equals to CB, which concludes that the product of extremes is equals to product of mean. Now, this is the basic principle of proportion. But we are also at times asked to find out certain terms like the fourth proportion, the third proportion, the mean proportion, the concept of continued proportion. So we will be seeing what are those terms. Firstly, if A is to B is proportional to C is to D, then D is called the fourth proportional term. Then D is called the fourth proportion. And how will we calculate this? Because we know that A into D equals to B into C. Therefore, D equals to B into C by A. So the fourth proportion is calculated by using the formula, the product of the means by one of the extreme terms. If it is given that A is related to B and they are proportional to B is to C, and A, B and C are in continued proportion, and C is the third proportion. Why third proportion? Because here there are three different terms, A, B and C. So C is called the third proportion. So from here, again applying the same formula, the product of means divided by the product of extremes, we get C equals to B square by A. If it is given that A is to X is proportional to X is to B, then X is called the mean proportion. X is called the mean proportion between A and B, and using the principle of product of means equals to product of extremes, so X square equals to AB, which follows X equals to root over AB. So the mean proportion is found out by finding the square root of the product of the extreme terms. X equals to root over AB. And now coming to the concept of continued proportion. Continued proportion. When we talk about continued proportion, suppose it is given A is to B equals to B is to C. The terms are in continued proportion means A by B would be equals to B by C. That means the ratio of two consecutive terms would be equal. And that is what is meant by continued proportion. Sum number 1. If Q is the mean proportion, if Q is the mean proportion of P and R, then prove that PQ plus QR plus RP divided by P plus Q plus R whole cube equals to PQR. If Q is the mean proportion of P and R, then prove that PQ plus QR plus RP whole divided by P plus Q plus R whole cube equals to PQR. Now in this sum, since Q is the mean proportion, Q is the mean proportion of P and R, implies Q square equals to PR. So if we look at the RHS, where we have PQR, which can incidentally be written as PR into Q, this becomes effectively Q square into Q, which is Q cube. Now, if we look at the LHS, PQ plus QR plus RP divided by P plus Q plus R whole cube. So this can be written as PQ plus QR plus RP can be replaced by Q square by P plus Q plus R whole cube. So from the numerator, if we take Q common, so Q comes out. So in fact, Q cube comes out. We are left with P plus R plus Q divided by P plus Q plus R whole cube, which is effectively Q cube equals to RHS. PQ plus QR plus Q square by P plus Q plus R whole cube. So this can be written as Q into P plus Q plus R by P plus Q plus R whole cube. So if I take Q cube outside, it will be Q cube by P plus Q plus R by P plus Q plus R whole cube, which is Q cube. If X, Y, Z are in continued proportion, if X, Y, Z are in continued proportion, prove that X plus Y whole square divided by Y plus Z whole square equals to X by Z. Now the solution for this sum is X, Y, Z are in continued proportion means X by Y equals to Y by Z, implies Y square equals to XZ. If we have Y square equals to XZ in the LHS, X plus Y whole square by Y plus Z whole square equals to X square plus Y square plus 2XY by Y square plus Z square plus 2YZ. Now this can be written as X square plus XZ, replacing Y square by XZ, plus 2XY divided by XZ plus Z square plus 2YZ. So from the numerator, I take X common. I am left with X plus Z plus 2Y. From the denominator, I take Z common. I am left with X plus z plus 2y. Effectively, this reduces down to x by z, which is my right-hand side. The question is, what number should be added to 5, 11, 19, and 37 so that they become proportional? Simple. Because the number is not known, let the number to be added be x. So we have 5 plus x by 11 plus x equals to 19 plus x by 37 plus x, which incidentally means the product of the extremes will be equals to the product of the mean. So from here, 5 plus x into 37 plus x is equals to 19 plus x into 11 plus x. So 185 plus 42x plus x square equals to 209 plus 30x plus x square, which means 12x equals to 24, or x equals to 24 by 12, which is 2. So the number that needs to be added is 2. The question is, if three quantities are in continued proportion, then prove that the ratio of the first to the third is the duplicate ratio of first to the second. Now, since it is mentioned that three quantities are in continued proportion, let the three quantities be A, B, and C. So if they are in continued proportion, we will have B square equals to AC. How do we have this? We have A by B equals to B by C, implies B square equals to AC. Now, duplicate ratio of first and second. So duplicate ratio of first and second would be A square is to B square. Now, A square is to B square means A square is to AC, because B square equals to AC. So we can write A into A is to A into C, implies A is to C. Now A is to C means the ratio of the first and the third term, which is the required proof proportion. Now we'll be discussing some important properties of proportion. Some important properties. The first property that we'll be discussing is called invertendo. Invertendo. What does this property mean? That means if A is to B equals to C is to D, then invertendo means when we invert the numbers, then B is to A would be equals to D is to C. If A is to B equals to C is to D, then B is to A equals to D is to C. Alternando. If A is to B equals to C is to D, then according to alternando, we will have A is to C equals to B is to D. That means the terms will get alternated between themselves. So we'll have A is to C and B is to D. Componendo. Componendo is if A is to B equals to C is to D, then A plus B is to B equals to C plus D is to D. I'll just show how it is done. If A by B equals to C by D, that is A is to B equals to C is to D, next step would be A plus B. That means in the numerator, we are adding the terms of the numerator and denominator. In the numerator, we are adding the terms of the numerator and denominator. So a plus b by b equals to c plus d by d. Since we know a by b equals to c by d, if we add 1 to both the sides, the original equation does not change because we are adding 1 to both the sides. Now, taking the LCM, we will have a plus b by b equals to c plus d by d. Dividendo, which says if a is to b equals to c is to d, then a minus b is to b equals to c minus d is to d. Again, if we have to show how it comes or how we arrive at this, a by b minus 1 equals to c by d minus 1. That is, we are subtracting 1 from both the sides. If we subtract 1 from both the sides, we will come to a minus b by b equals to c minus d by d. The last and the most used property, which is a combination of componendo and dividendo, and we call it componendo and dividendo. The terms which we are getting in componendo, we divide it by the terms which we get in dividendo. If this is considered as equation 1 and this is equation 2, when we divide equation 1 by equation 2, we get to componendo and dividendo. That is, a plus b by a minus b equals to c plus d by c minus d, which can also be written as if a is to b equals to c is to d, then a plus b is to a minus b equals to c plus d is to c minus d. If a is to b equals to c is to d, show that (3a plus 2b) is to 3a minus 2b equals to 3c plus 2d is to 3c minus 2d. So first method, a by b equals to c by d. Why? Because it's given a is to b equals to c is to d. Now let us consider that this is equals to a constant k, which means we can write a equals to bk and c equals to dk. If that be the case, then 3a plus 2b by 3a minus 2b can then be written as 3 into bk plus 2b by 3 into bk minus 2b. So if I take b common, we'll have 3k plus 2 by b 3k minus 2. So effectively it comes down to 3k plus 2 by 3k minus 2. Similarly, if we look at 3c plus 2d by 3c minus 2d, we'll get 3 into dk plus 2d by 3 into dk minus 2d. That is, if we take d common, 3k plus 2 by d 3k minus 2, which is 3k plus 2 by 3k minus 2. Hence, we have proved that the terms are equal because 3a plus 2b is to 3a minus 2b is the same as 3c plus 2d is to 3c minus 2d. If we move on to the second method, it is given a by b equals to c by d. So let us multiply the numerator in both the sides by 3 and the denominator in both the sides by 2. So we will be getting 3a by 2b equals to 3c by 2d. Since multiplying both sides by 3 by 2. If that be the case, then by directly applying the method of componendo dividendo, we can write 3a plus 2b by 3a minus 2b equals to 3c plus 2d by 3c minus 2d. So effectively, this becomes a two-step sum. But here we have to write componendo and dividendo. If p equals to 4xy by x plus y, find p plus 2x by p minus 2x plus p plus 2y by p minus 2y. So while solving this sum, it is given p equals to 4xy by x plus y. So from here, we can definitely write p by 2x equals to 2y by x plus y. We can write p by 2x equals to 2y by x plus y. So now applying componendo dividendo, applying componendo and dividendo. So what will we have? We will have p plus 2x. If we apply componendo and dividendo, we will have p plus 2x by p minus 2x equals to 2y plus x plus y by 2y minus x plus y, which is 3y plus x by y minus x. So again, we have p equals to 4xy by x plus y. So p by 2y equals to 2x by x plus y. So p plus 2y by p minus 2y, applying componendo and dividendo, equals to 2x plus x plus y by 2x minus x plus y. So we will have p plus 2y by p minus 2y equals to 3x plus y by x minus y. Now our main objective is to find the sum. So p plus 2x by p minus 2x plus p plus 2y by p minus 2y equals to 3y plus x by y minus x plus 3x plus y by x minus y, which can be written as 3y plus x by y minus x minus 3x plus y by y minus x. So, if we take the LCM as y minus x, we will have 3y minus y plus x minus 3x, which will be 2y minus 2x by y minus x, which will be 2 into y minus x by y minus x equals to 2. Prove that x square minus y square is to x square plus y square equals to x minus z is to x plus z. X, y, z are in continued proportion. That means x by y equals to y by z implies y square equals to xz. If that be the case, and we are in need to find out x square minus y square is to x square plus y square, we can simply write x square minus xz by x square plus xz. So if I take x common, x minus z by x plus z. So it will give us x minus z by x plus z, which is x minus z is 2x plus z equals to RHS. If a cube plus 3ab square divided by b cube plus 3a square b equals to 63 by 62. Find a is to b. The question is a cube plus 3ab square by b cube plus 3a square b equals to 63 by 62. So simply using componendo and dividendo, using componendo and dividendo. Why we are using componendo and dividendo? After I use it, you will get to know. We will get a cube plus 3ab square plus 3a square b plus b cube divided by a cube plus 3ab square minus 3a square b minus b cube equals to 63 plus 62 by 63 minus 62. What was the advantage of using componendo and dividendo here? You see, the numerator a cube plus 3ab square plus 3a square b plus b cube. This is effectively a plus b whole cube. The denominator a cube plus 3ab square minus 3a square b minus b cube. This is effectively a minus b whole cube. And this is coming as 125 by 1. So effectively, in the next step, we can write a plus b by a minus b whole cube equals to 5 by 1 whole cube. For that matter, we will get a plus b by a minus b equals to 5. If we cross multiply, a plus b equals to 5a minus 5b implies 6b equals to 4a implies A by B equals to 6 by 4 equals to 3 by 2 implies A is to B equals to 3 is to 2. It is given x equals to root over A square plus B square plus root over A square minus B square divided by root over A square plus B square minus root over A square minus B square. Prove that B square equals to 2A square x by x square plus 1. X by 1 equals to root over A square plus B square plus root over A square minus B square by root over A square plus B square minus root over A square minus B square. Using componendo dividendo. Using componendo and dividendo, x plus 1 by x minus 1 equals to root over A square plus B square. Achha, let me write. A square plus B square plus root over A square minus B square plus root over A square plus B square minus root over A square minus B square whole divided by root over A square plus B square plus root over A square minus B square minus root over A square plus B square plus root over A square minus B square. Effectively, this comes down to 2 into root over A square plus B square by 2 root over A square minus B square. If we now square both sides, so we will have x plus 1 whole square by x minus 1 whole square equals to A square plus B square by A square minus B square. X plus 1 whole square by x minus 1 whole square equals to A square plus B square by A square minus B square. This is what we got. Applying componendo dividendo again. Applying componendo and dividendo. Applying componendo and dividendo, we'll get x plus 1 whole square plus x minus 1 whole square whole divided by x plus 1 whole square minus x minus 1 whole square equals to A square plus B square plus A square minus B square whole divided by A square plus B square minus A square plus B square. X square plus 1 plus 2x plus x square plus 1 minus 2x whole divided by x square plus 1 plus 2x minus x square plus 1 minus 2x equals to 2a square by 2b square, or 2 into x square plus 1 by 4x equals to a square by b square, implies b square equals to 4a square x by 2 into x square plus 1. which is effectively 2a square x by x square plus 1, which was our RHS. If ay minus bx by p equals to cx minus az by q equals to bz minus cy by r, prove that x by a equals to y by b equals to z by c. Now the question is, x by a equals to y by b equals to z by c. Ay minus bx by p equals to cx minus az by q equals to bz minus cy by r. This is given. Now, see, we will be using a trickery in this sum. What kind of trickery? We will be using, this is a more of a typical kind of a sum. And here we will use the trickery or the technique to solve the sum in an easier and a more comfortable way. If we look at the first term, it contains A, B, but any term related to C is absent here. I repeat, in the first term, we have terms containing A and B, but any term containing C is absent here. So what we do here is, we multiply the numerator and the denominator by C. Similarly, in the second term, none of the term constituting B is present. So we multiply B with the numerator and the denominator. And similarly, A is multiplied to the third term. So let's now, we are adding all the terms. Let us add all the terms. That is, we will have so if we add all the terms, then what will we get? We will get it as now the important question which arises here is, how do we get to this? A small property, which is, if A by B equals to C by D equals to E by F equals to dot dot dot, then the ratios, what are the ratios? Suppose if we multiply these terms, P a to the power n plus Q c to the power n plus R e to the power n plus dot 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 by P b to the power n plus Q d to the power n plus R f to the power n plus dot 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 to the power 1 by n. This comes from a property which is called addendo, but addendo is not in your syllabus. So if n equals to 1, we will get it as PA plus QC plus RE plus dot 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 divided by PB plus QD plus RF. So this is the property. Now, if this be the case, this will equate to 0. So if this equates to 0, we will get from here, what we get in the next step is either for this to be 0, either AY minus BX equals to 0, CX minus AZ equals to 0, and BZ minus CY equals to 0. If that be the case, then AY equals to BX implies X by A equals to Y by B. CX equals to AZ, which means, or we can write X by A equals to Z by C. BZ equals to CY. From here we can write Y by B equals to Z by C. Implies we will have X by A equals to Y by B equals to Z by C.